I'm Duncan Robertson and I'm a software engineer at Kyan. I'm going to do a talk on generative AI, specifically about a product called Stable Diffusion, but text-to-image generation in general. So if you want to find out any other posts that I've written, if you visit kyan.com/news, you'll find them there. So let's start with some of the high-level stuff. So what is AI for starters? Because the word's used a lot. So AI is a wide-ranging discipline that covers lots of sub-disciplines. They're like robotics, visual computation, machine learning. They all come under the AI umbrella. The machine learning part is kind of the brain. So it refers to computers learning from data without being explicitly programmed. And then a machine learning model, which I'll use the word model a lot, is a file that's been trained to recognize certain types of patterns. You train a model over a set of data and then provide it with an algorithm that it can be used to reason over and then learn over time. So generative AI refers to artificial intelligence that can generate novel content rather than simply analyzing or acting on existing data. So, So in fact, Andy West spoke about generative models some time ago when he talked about GPT, which is human-like text like GPT, but it's also able to generate like stories and poems and computer programs and software and recipes and all sorts of crazy stuff. So, but the G in both of GPT and ChatGPT stand for generative. So essentially, generative AI, when given an input, is able to create an output. So in this example, so given text, email, social media content, images, voice recordings, it's able to generate an output. So it can generate stories, blog posts, programs, songs, poetry, a lot. You can see instructions, but at the bottom you've got like music, images, and even video. So we're going to deal with images. That's the part of generative AI that we're going to look at. So a couple of examples of what that is. So that is where you provide, so the part of generative AI we're looking at is called text to image. And text to image is, as this looks, you pass it some text and it gives you an image back. So these are ones that I just did on my local machine. So I asked it for, you can see a child's drawing of some robots, and this is the image it gave me back. A couple of other examples. Gave it a cute dog wearing a hat. I guess the thing up front, which you may know, that these images are not real images. They're kind of generated. They're completely unique. Sometimes that's a bit of a hard, I know when I started looking at this, I found that really hard to grasp, that this image doesn't exist anywhere else. It's literally just first been seen by me now because it's just generated. But you can see we start off with simple prompts here, and they get more complicated. So an old photo of a landscape with mountains and a lake, and again, pretty compelling. And then it gets up to like crazy stuff like this, where you kind of can give it enormous amount of detail and you get a pretty astonishing images out of it.
Is that you, Duncan?
Yes. Okay, so there's lots of players in this field, but I guess I picked four of the biggest really. So we've got DALL-E, which is it appeared in 2021 and comes from OpenAI, the same company that builds GPT and ChatGPT, which is a company that Elon Musk founded a bunch of years ago. And actually DALL-E is kind of GPT, but just for images. So it just swaps text for pixels. It's closed source, so no one knows how it works. And until September last year, the API to actually generate any images was only available to a very small few people. But now I think you can actually pay and use its API to generate images. But it's quite expensive. And you might have seen in the press that recently Microsoft did a big deal with OpenAI in order to kind of use this in some of its upcoming products. And I think there's a few I posted in the AI channel here that there there was a demo of one of their design products already using generative AI in them, and it's pretty mind-blowing. So another player is a company called Midjourney. They're an independent research lab, and again they only started in July 2022 last year. You'll find that there's a theme with all of these generative AI products. They all happened in the last 6 months. It's just mind-blowing. I mean, I guess they've been trickling under the radar for a while, but they all seem to have only been released in the last 6 months. So this is also closed source. You can't get access to any of the software, and actually you can only generate images through Discord, the chat bot. There is no API or website or anything. They do promise they're building a website, but currently there isn't one. I'll talk about it later, but it was Midjourney that was used to generate the book in illustrations in a controversial book called Alice and Sparkle. Now, next one, Imogen. This is Google. So this came out May last year. It is not available to the public. In fact, Google specifically didn't release it to the public, citing ethical issues at the time, because this model the images that it was trained on were just random images scraped from the internet, so they weren't kind of pre-processed or validated in any way. So they were a bit, so they purposely haven't open sourced it and allowed anyone to use it. It'd be interesting to see now that Microsoft has done a deal with OpenAI, whether they change their mind, whether they think that might impact their search engine business. I guess we'll have to watch this space. And then the final tool that we're going to talk about today is the relative newcomer, really, and it's called Stable Diffusion. All these tools work in the same way, but it's Stable Diffusion we're going to talk about today. So Stable Diffusion, and the reason we're going to talk about it is because, so it was released in October last year, which doesn't feel like that long ago, really, and that was its first version, 1.5. The big reason that Stable Diffusion has got so much press is because it's free. You can download it and run it on your own machines. The model that was being trained is free for you to use and do with not whatever you like, but it's you can pretty much. And what that's meant is, and also it can run on consumer machines. Generally, these kind of softwares require super processing power, but this one's specifically been developed to run on just laptops and small servers. So if you look online now and type Stable Diffusion example or demo, you can basically find this running online, where you can type in some images and you'll get you type in some text and you'll get some images back. So it's not hidden. It was trained on images that are only 512 by 512 pixels. It was trained on over 1 billion images and text pairs. So I'll talk more about briefly how this thing works, but essentially you have an image and some text that represents that image. That's what that means. And you can see it was trained on a lot of images that were actually curated. So they're not just any old images, but a lot of images, and they're all very English specific, those images. So this kind of model, that's another conversation around the kind of ethics behind it, but it is very English centric. It took 150,000 hours to train, just as an example of how much it costs to train these models. 150,000 hours, £600,000, and the machines are super, super powerful. So it's not really something you can do in your house at the moment. It's like big tech. And like I said, it can be easily installed on your personal computer. So Stable Diffusion, like all these other tools, use something called a diffusion model. And the bigger reason we're talking about Stable Diffusion, like I said, is because it's open sourced. The project was a collaboration between lots of different companies, one that provided the images, one that provided the hardware to run it on. And one of these companies is called Stability AI, which has basically marketed this kind of technology, and that's where the name Stable comes from, and diffusion comes from the fact it's a diffusion model. I just talked about version 1.5 that came out 6 months ago. So this was version 2.1 that came out less than a month ago, which is crazy, the speed that they're developing this. And now that one generates much larger images. It creates even better looking images, much more high fidelity for less. You don't have to be so specific for it to seemingly understand what you want. Interestingly, version 2 has become safe for work, whereas version 1 is not safe for work. So some of the images were possibly controversial, I think mainly around nudity, has been removed from the version 2. You can imagine the internet loved that, both sides. And also, again, we'll talk about a bit more, but a lot of the artists and styles have been redacted from that data. You know, there was a lot of artists that were being used in the prompts and because they wanted images to look in the specific style, and obviously, version 2, it feels like they're listening to the critics, and the version 2 has kind of redacted a lot of this, but then gave extra features on top. So you can still create, I mean, you know, it's pretty crazy images really that it generates, but
Are those just living artists, or are they all artists that got redacted?
So no, it's definitely not all. It's a very, very, very small subset at the moment. I think we'll talk about the ethics later on, but it's only a very small subset. So basically things are moving fast. So everything I'm showing was generated in version 1, mainly because version 2 I found really hard to run locally. It just wasn't so easy to actually run, because it's such a fast-moving product for someone, you know, like me to have a play with it. The documentation is never up to date. You know, getting something to run is a bit like maintaining a very old car. There's a lot of tweaking and pulling just to try and get it to generate something. So everything I'm showing is version 1, but you can see version 1 still kind of produces some fairly crazy stuff. So we're going to talk a bit about how diffusion models work. Hopefully this is not going to be too crazy. I've tried to, I mean, to be honest, I can't understand a lot of it, but I'm going to try and explain what I understand in a way that hopefully you understand too. So let's start. So what are diffusion models? So it's a huge neural network. That's to start. So a neural network is a type of machine learning model that's been designed to process data in a way that's inspired by the human brain. So it is a type of machine learning process called deep learning that uses interconnected nodes or neurons in a layered structure that resembles the human brain. So it's basically trying to replicate how our brain works, but in computers. The truth is, well, this is a bit of the TLDR. The truth is they don't actually know how some of it works inside. I'll go on to that. I mean, that's a bit of a crazy statement, but I'll talk about that a bit later. But there's some aspects of it they don't really know how it works yet. And essentially the way that these images are generated is they're just removing noise from images. And again, we'll talk about how that works, but let that one stick with you. All this thing is removing noise from images. So this is a noisy image. It looks, you can kind of make out what it is, but you can imagine a version of this photo with more or less noise added, and it would make it more or less visible to you, or distinguishable of what the actual makeup of the image is supposed to be. So Stable Diffusion is able to remove the noise that you see there. So it's able to just clean up images. It's much more sophisticated than that. It's not like a noise removal tool in some image editor, but it's clever because it kind of has an understanding of what the world looks like. So it has an understanding of written language. So it's able to leverage all of this information that allows it to guide it through the process of removing the noise. So for example, imagine if I gave the image on the left to a skilled graphic artist and told them that it's a painting of an alien playing a guitar in the style of H.R. Geiger. So they'd be able to go away and painstakingly clean it up to create something like the image on the right. But this is essentially what Stable Diffusion is doing when it's generating images. So most of the art generation tools we have a setting called inference steps. That's because those and Stable Diffusion removes noise incrementally. So in the previous example, it makes more sense because you could kind of make out what the image was up front. So you could you'd understand what it was going to end up as. But in the image above, you can see it starts with something completely unrecognizable and ends up with a picture of a dog. So this, sorry, I need to scroll up. So we give stable, so when you give these, I'm always talking about Stable Diffusion at the moment, but it could be said for any of them. So we give Stable Diffusion a starting image that is actually nothing but pure noise, but then we also tell it something like a photo of a cute dog outside wearing a hat. And then we ask it, can you clean this up for me? And so it can impossibly then go and create that image from that noise. It will clean up that noise until it basically ends up with the picture that you expressed. So the deeper answer of how it's doing this is the fact that AI models, or more technically machine learning models like Stable Diffusion, are heavily based on statistics. They estimate probabilities for all of their options. And even if all of the options have extremely low probabilities of being right, they just pick whichever path has the highest probability. So for example, it has some idea of the areas where a dog's nose may go in an image, or where a hat may sit on an object. Even though there is really no right choice, it just starts filling things in. And since there's no right answer, every time you give it a different image of pure noise, it's going to come up with a completely different piece of artwork. So how? This is pretty crazy. Okay, so based on how we build things at Kyan, if I was trying to guess how this is actually implemented, I'd probably start to think up how would you program it? In other words, what's the sequence of steps that it follows? Maybe it's matching that prompt, the keywords in that prompt, and then using that to search a database of images that match the description that I've put in. And then it compares them with the noise, and then it starts layering them on. So no, it's got nothing to do with that whatsoever. In fact, it doesn't have a database of images. It doesn't use any image processing at all. It's all just pure maths, lots and lots of maths. And I don't really mean the maths that we do when we're writing software. I mean the kind of bewildering complex equations on a chalkboard maths like this. So this was just, I found this was just a really, really tiny fraction of the logic that's used during the process. So imagine this times 1,000, and that's kind of, you're heading towards what's going on inside these diffusion models. So this is very quick, this is to try to get an idea. So in order for it to do the maths, it needs numbers. So kind of what it does is it converts everything that it's got currently into numbers. So the prompt, this is on the left-hand side, you can see it says a long exposure color photo of just on the left. So Stable Diffusion converts that into numbers, a big long matrix of numbers that you see on the left. And then it does the same, it takes the noise that you start with, and it basically takes it breaks it up into red, green, and blue, and each pixel, and it converts into numbers. So you just end up with lots and lots and lots of numbers. And they're not even simple numbers, they're like complex numbers, as in they've got lots and lots of decimal points. So, like the noise image is comprised of about 800,000 numbers, and then the left-hand side is comprised of like 25,000 numbers, so lots. But unbelievably, that isn't the biggest set of numbers that is required, because there's a much larger set of numbers that's actually plugged in as well. And they're the same numbers that get used for every single image that you generate. And they're called Stable Diffusion's parameters. So this is a little bit of going back to school maths. So you may remember plotting lines in school with equations like this. So if this was Stable Diffusion, then X is our input text, Y is the final image, and 3 and 2 are the parameters that I mentioned earlier. So this equation obviously is ridiculously, obviously this is quite simple, and the equations in Stable Diffusion are just incomprehensibly more complicated. So there's roughly 1 billion parameters that Stable Diffusion uses. And those billion numbers are spread out across thousands of different matrices of varying sizes. So a matrix is an arrangement of numbers into rows and columns. And each matrix is used at a different point during this maths that is used. It's just mind-blowingly complicated. So these billion parameters, so no one chose them, and that's the bit that they can't explain. That what those values are, no one understands. So no one chose those numbers, and no one can really understand what those numbers should be. But that's kind of how these models work. A lot of I think I've written that some of the engineers have an intuition about what some of this means, but that's all they have. So initially, before being trained, the way the model would start by picking 1 billion random numbers. And with those initial random numbers, the model is completely useless. So to start off with, you could provide it with some noise and it would not produce anything resembling an image because it just doesn't know what that is. And then over time, a process is applied which is referred to as training. So if you've looked into AI, they always talk about training a model. So it's training. And training gradually adjusts those billion parameters to ones that start working better. So training involves massive amounts of data, huge data sets. And those data sets contain images, noise, and text. So on the left, you can see each of on the left-hand image, slightly more noise is being applied. So that's another entry in the training set. And then as you gradually provide this information into the model, the numbers get tweaked slightly and you start getting a better output. Rather than getting no output, you get a better output. And then over millions and millions and millions and millions of iterations, you start getting to a point where actually the values can't be tweaked anymore. The results are what you want. And it's those values that get turned into a model, and it's the model that is what is released to the public to then use to then generate their own images. Because like I said, those parameters don't change. Once they're set, they don't get changed, and you can then use them. So you can see that when we generate an image, we start with noise and we start removing it to generate an output. But when we train a model, we start with an image and then progressively add noise during the training process. So it's able to reverse what it learns. So a very important part of these text-to-image models is the text, and it's known as the prompt. When I first started looking at this stuff, it always used to say that the prompt is just a natural language input. But it quickly became clear, and you can probably see it here, that the best results that you get back are created by anything but natural language. So these images on the right are not originals. They were all generated with this same prompt. I just happened to run it 4 times in a row. So the prompt is so important that the creation of them is starting to surface a new job title. I guess you could call it a prompt engineer, if you will. So prompt engineering is the process of structuring these words so that the text-to-image model can best interpret and understand them. It's kind of like a programming language for image generation. Stable Diffusion uses the prompt to guide it towards the final image. So this is the more specific your prompts, the better chances you'll end up with an image you imagined. It means you really have to think about what you want to generate. And just to add a bit of jeopardy, the order in which you put the text in the prompt actually affects the output. So this is a non-exhaustive list, but it's just so you can get the idea of possible terms that can be used. And this list just comes from people's experiments, because there's not like an API or documentation to say here's all of the text that you could use. So so as people find better results, this vocabulary seems to be increasing. And Stable Diffusion was, like I said earlier, Stable Diffusion was trained on millions and millions of text-image pairs, so there's lots of text in there. So the prompt is evolving all the time. In fact, in version 2, so I'm showing 1.5, but in version 2 they extended the prompt, so you don't only put in what you want to see, you can actually put in what you don't want to see. And you can also kind of emphasize part of the input to say, I want it to be more this thing. So I've just got some 3 simple examples. That was the initial prompt, just asking for a forest. And then the second one, I asked for the same thing, but I just said I don't want any green in it. So it gave me back a red one. And then the final one, again, didn't want any green, but I just asked it to emphasize the word fantasy. I'm not sure I think it did. It felt like it did, but I guess that's objection. So so that's how the prompt works. So the prompt is so important that loads of new websites have actually sprung up that are just dedicated to dealing with writing a good prompt. So this is a really popular one called Lexica, which just provides lots and lots of images and then provides the prompt that was used to generate that image and any other information that's required, because the generation of these images isn't, although it is called text to image, there's lots and lots of options that you can set and values you can set going along to generate varying different sorts of output. And there's another one, this is called Prompt Mania, so this is even more specific. And this one actually guides you through creating a prompt. So you start with what sort of model you're using, and then it asks you, what do you want in your scene, and what sort of lighting do you want, and the sort of colors. And you basically, you just click buttons, you don't really type anything in, and at the end you just get this prompt that you can then paste into your, paste into the varying tools, and hopefully you'll get some suitable output. So that's the prompt. Next, we're going to talk about some of the features other than text to image. So other than just text to image, putting in some text and outputting an image, Stable Diffusion includes lots of other mechanisms for generating images and manipulation. So we'll look at a couple of these, starting with in-painting. So as the name infers, this is the process of drawing inside something. So it's done by you mask an area of an image that you provide as an input, or one you've generated, and then you let the model redraw again, and it will only redraw inside that masked area using the prompt that you provide. It's kind of the equivalent of what Helen does, but in computer form. So, what's pretty mind-blowing about it is that it copies, and it kind of looks like me, but I didn't provide any pictures of me glancing sideways, It's basically copied the original photo in terms of the composition of where the face is pointing and all of the lighting and everything like that. And I think that goes a long way to why they're sometimes quite compelling to look at, because they just look, it's the lighting and the composition that makes them look really quite real. Next is outpainting, which is, again, pretty remarkable. So this is the opposite of in-painting. So this is where you provide an image and it will attempt to draw outwards, again, guided by the prompt. I must admit, I tried, for a lot of the examples I've got, I did on my laptop because I kind of wanted to show that what it could be done rather than use assets from other places. But this one I couldn't actually get to work. The demo one that they provide is far better than all the ones I did, so that's why you're seeing this. But I've seen some other interesting ones where there was a picture of a lady in a street, or looked like she was in the street, and then they outpainted, and she wasn't in the street, she was in the middle of some amazing landscape, and it just kept drawing. Yeah, amazing. Okay, what's next? Clip integrator. This is interesting because it's actually not generating images. It is where you pass it an image, and it basically it gives you back the prompt that would create a similar image. So in this instance, I gave it the image on the left, and it gave me back the text on the right. and genuinely, I didn't write the text on the right. I was pretty, because I just picked that image at random from the internet, and I was thinking, I might have to choose another one because it's not going to know what this is, and it really does know what this is. So I found that pretty amazing. So that functionality, this functionality actually uses another AI model that's built into Stable Diffusion called Blip, and it's Blip that's able to understand images and convert them into text. I've written that this kind of thing feels like that could be, there's a use case for that, an easy use case for that, like generating alt text for images for websites, for example, automatically because alt text obviously gives you some more SEO and like not having to, letting these sort of tools just generate it for you if there's none there, rather than having to rely on someone having to fill it in. Because of all the experiments I tried, the actual generating of images with text is actually requires a lot of curation, which I'll talk about later. But actually, this seemed to just be amazing every time. I'm almost as blown away with the way that it's able to understand what an image is than I am actually the generation of the images. Okay, so next, image to image. So this is where you provide a guidance image, and it then goes and tries to it uses that image to try and continue to generate an output image. So in this example, the kind of sketch on the left was fed into Stable Diffusion, and then the output was the second image. So that's what it got back the first time. And then the second image was then fed into Stable Diffusion. The second image was then tweaked in Photoshop to kind of make it a bit more high fidelity. And then that resulting image was fed back into Stable Diffusion, and the output image is the one on the right. So I don't know, it just, with a bit of Stable Diffusion and a bit of a graphical artist, you were able to go from that sketch to this result really quickly. I mean, that's cool. And then, so that's what image to image does. Another use of image to image is something that I did actually when I was trying to understand it. So that's image cleanup. So on the left, my mum had sent me an image from some distant relative who we don't know the name of, and you can kind of see that she tried to fix it with some crude tool and made some, I don't know what she'd done there really, but she messed it right up. And I was just interested to see what would happen if you fed it into Stable Diffusion and tried to see if it could regenerate it. And I mean, I'm sure we could pick it apart and find details that are not right, but I was just, again, that was pretty crazy, really, the output that it was able to give. I did it with a couple of them, and they were pretty amazing. I think I've showed a few people. I did one with a child's photo, and although the resulting child had a slightly chubbier face, it's still to the untrained eye was amazing.
Is there any text prompt to that as well, or you just put the image in and see if it do something?
I actually didn't know. I didn't use any. I don't think I used any prompt on those ones. No, so I didn't guide it in any way. But I did. There was a toggle that said something like clean up faces, or I think there's a specific model that's really good at taking pictures and knows what a face looks like, so it's able to adjust it to look more facey. So it kind of, and they use it to clean up photography, because I think that's, cleaning up photographs is like an industry, taking old photos and art and films. So I think it's just taking a small snapshot of that and using, But it's pretty impressive because that's the first thing that came out. I didn't tweak it. I specifically didn't spend a lot of time. I just thought I'd try it and see what came out. I was quite impressed. So that's image to image. Next is fine tuning. So fine tuning is the practice of taking a model which has been trained on a diverse data set and then training it a little bit more on something very specific that you want to generate. And the results of this are both amazing and alarming at the same time. So for all the amazing things that AI image generation is capable, it appears to be making yourself look like Iron Man is the thing that people are most interested in. So, and in fact, like there's lots of businesses that have been created around doing just this right now, where you pay some money, you provide a bunch of images, and they'll give you another bunch of images back like this. It's the internet, don't ever give anyone your images, and if just don't use these services, you're basically, you're giving someone carte blanche to generate all sorts of crazy stuff of you, because these are only the nice things. So Dream Booth is a version of this fine-tuning that the researchers at Google created, and it's another of their products that actually they held back releasing for quite a long time due to concerns about how it was going to be used. And it was originally developed for their product, Imagen. So that Dream Booth paper was then taken by a very clever individual and re-implemented for Stable Diffusion, and that's what I'm using there. So this kind of, the process of retraining the model requires lots of compute power. To do this, I had to rent some computers with big GPU cards and use them. I provided it with like some images, and then 20 minutes later it was able to generate me a model that I could then, in the prompt, I could use my own name and I would be part of that photo. So I think I've said that. Steps I follow, so that's how I generated those, and it was quite straightforward to do, and I've got that model. I can do whatever I like with it, but it's mine, and I did it on my computer, so it's not like I gave it to someone else. So a couple of more examples of this fine-tuning, the difference, because that was just my face. So this is an example I found on Twitter actually, a handle called M. He experimented by taking 16 of these little buildings from a game called, I think Red Alert Command and Conquer. I've not played it. He took some of these buildings and he fed it into Stable Diffusion to train, and then he asked the model to generate some more buildings using that trained model, so you can see. So then he handpicked the results from that and then fed it back in again, training it on specific types of images, and eventually he was able to get to a point where he could basically generate these buildings on demand. And these are a couple of the examples. So, asking for a factory, he gets lots of unique factories, asking for a nuclear power station. This fine-tuning, there are some pitfalls with fine-tuning. For example, you don't appear to be, like with the image one that I showed earlier, you don't appear to be able to train two people with the same model. So I tried to train it with me and another, I think my son at the same time. And whenever you generate pictures, they just look like me and my son with the same face. They're really creepy. So it doesn't seem to be able to distinguish between two people. It just morphs them into a single character. And the model that you get back, so the model that I keep describing is about 4 gig inside. It's quite a big file. But when I did the fine tuning, the model I got back was like 2 gig. So somehow it's lost half of something. But I don't really know what it's lost, but it's lost half of something, so that doesn't seem like that's good. So that's the pitfalls on fine-tuning. The pitfalls in general with this AI image generation stuff, there's quite a few of them. You might see them in the photo. So some of these are being fixed in future versions, but some of them aren't. So let's talk about what some of these are. So it tends to fuse 2 subjects into a single subject when they're less common. So in the bottom left-hand corner, you can see we've got a giraffe-elephant combo there. Just because they're uncommon concepts, it doesn't seem to understand, so it just morphs them into a single crazy...
For a hybrid animal?
Girelephant. No, I think it's meant to be a giraffe and an elephant.
Got
but
one
it's
of those in his Dark Materials.
And they're also, they're not very good at limbs, it's fair to say. I mean, that creepy photo of me, that is weird. And then the hat, something not quite right. And then, these hands here, look, I don't really know what's going on there. And also, even with what looks on the surface as a beautiful image, the more you look in detail, the more likely you're to find many imperfections in that. I think what these things are, they're great at generating something that you glance at and just think, that is amazing. But then when you look further in, you then start to see more of the imperfections. But for some reason, our brains don't see those imperfections straight away, and you just think, oh, that's beautiful. But actually, it's generally a bit broken as you get inside. And then lastly, all the images that I've shown, they're not always generated the first time I put that prompt in. I think that's a bit of a take home, really, because all of the stuff you see online of these beautiful images that are generated with AI art, the assumption is that you just type in something, you get this amazing bit of artwork out. But actually that isn't the case. Sometimes you have to render these things like 50, 100 times, because the first 50 just look hideous. They don't look like anything that you expect, and then accidentally one will appear and think, oh, that one looks good. So it's the case that it very much is curation rather than some magically generating the perfect art every time. Okay, next subject, because I realise I've been talking quite a while. Ethics and ownership. So I'm not gonna gloss over this. I'm going to talk about it, but it is a massive, massive subject. If you've ever looked in the news, yeah, and I think in the last week, I don't know how many different law cases have appeared with different companies, but they seem to be ever increasing. So that's interesting. So, and if you don't know what the ethics and ownership bits here, I've got a couple of examples. I guess the biggest one is an illustrator called Greg Rutkowski. He was like a famous illustrator he did a lot of the illustrations for like Dungeons and Dragons and Magic the Gathering cards. When Stable Diffusion first came out, people found that if you used his name in the prompt, the images came out exceptional. There was just a layer of fantasy that was added to them that just made any image look amazing. So his name was used in loads and loads of different prompts. But what that meant is all these sites like Lexica, for example, I showed you, if you do a search for Greg, sorry if I can't keep pronouncing his name, Rutkowski, like 95,000, I did one and 95,000 results came back. But all of those images are online. So it means that now when he types his name in Google, he doesn't see his own art. He only sees art that was generated with his work. So you can see where it becomes problematic, you know? His style is kind of it almost feels like it's not his anymore. So yeah, so that was a rough example. I've got some actual examples of both sides I thought I'd show. So this is, you might have read it, this is in the press. So this guy, Amar Reshi, he created a children's book one weekend. I guess I should caveat this with he's just a geek. He's not some kind of wanting to ruin the world guy. I think he's just a geek that was playing with AI and realized he could do this. But he created a book called Alice and Sparkle, where the images were generated by AI and the text was generated by ChatGPT. So he didn't really, all he did was assemble it. And then the mistake he definitely made was selling it then on Amazon. And it caused, massive controversy, you know, and I think he's taken it down now and he's given all the money he made to charity, but I don't think he realized the outcry it was going to cause. But what's interesting about that book, if you look at the book, the images are full of flaws. All the kids have really weird hands. And when you analyze the text is kind of incorrect, or, you know, it reads like it should be correct, but then some of you think, but that doesn't make sense. So that was one where it was controversial. This is an interesting one which has kind of created lots of buzz. So this was a Nigerian filmmaker who used AI to take couture fashion show images and add old people or older people in them. So instead of young models, he did AI to generate older models in the pictures. So I just took a few snapshots, but there's loads of them and they all look amazing. All of the photos look amazing. And he created a massive buzz where people are asking, you know, where can we buy these clothes? And, you know, this is amazing. I'd love to dress like this, you know. It was just a different take on creating, I thought it was really interesting using it in that way. So yeah, a different take on it. Okay, let's move on. Let's quickly go what we could do with this, because I've showed you all these different technologies. So I've got a few just off the top of my head ones, but I'm sure we could all come up with far better ideas. So the obvious one is opportunities around SEO. So, you know, this image to text thing. yeah, it feels like that would be an easy win, like automatically generating content that we would generally, generating content that we could easily auto-generate, because actually it's just describing an image, for example. And then another one is around maybe looking at, you get these pictures of two people stood around a screen, pictures on websites, which are kind of like non-photos. It feels like maybe, you know, AI could help with making them a little bit nicer. Then streamlining existing tricks for demoing. So this came off the back of thinking about the Clariol stuff we were talking about the other day, and when these vendors are selling like hair dyes or hair products for different hairstyles or makeup, currently they're kind of like a Photoshop montage on top of each other, and you end up with maybe something that kind of doesn't really look like a human, but it's just got different colored hair. But with AI, maybe you could create more realistic pictures of what someone would look like with these products on. And then finally, around the bright stuff is, you know, I guess one scenario I thought of is a user's searching for a specific illustration that they're interested in. They really like the artist, but the artist hasn't drawn the composition that they'd really like them to draw. So could you use AI to kind of pre-generate ideas of what, you know, I'd really like an illustration of this, and then the AI could generate lots of options, and then those options could be sent to the illustrator as kind of a, we're getting a lot of requests for this kind of image, you know, would you consider creating this sort of image in, you know, for them? So it's kind of, it's moving it away from the, it's stealing my art, to can it help? Yeah, that's, yeah, exactly, yeah, rather than, because a lot of the, I mean, I don't know which, I can understand why people find this stuff terrifying, but then as an engineer, I just, you know, some of this stuff I just think is amazing and can really help. So it's just finding that balance rather than always thinking of the down, just trying to think what could it be used for? It doesn't always have to, you know, and that's a scenario where I was thinking.
I think there is space for that.
Yeah.
I've come to that same.
Okay. And the other, I mean, as we all know, this, and I should have said this at the beginning, unfortunately, this technology is not going away. It will, like you said, it was only going to get better. So you kind of have to embrace early, really. You can't, I think hiding away from it's probably not the way to go, because, you know, these things just evolve and get better. Okay, final couple of slides. So this is the tool that this is what the interface for the tool that I've used to generate all the images looks like. And you can download this for free, and it runs on pretty much all of our computers. It's kind of, you just download it, run an install script. It's called Stable Diffusion. I can send out the link afterwards, but it's called Stable Diffusion Web UI. And it's just a tool that you run locally, and yeah, you provide it with the prompt up in the top left-hand corner. I guess this is, I think I showed this because I wanted to show that it's not just a text prompt. There's a lot of things that you can click and twist and bend and to change your output, and actually all of those settings do give you quite different results when you output them. But yeah, it's a really nice.
Is that just as a regular installer, or is it GZIP code that we need to?
I'm pretty sure you basically download it, and then it tells you run this command, and then that's it. And then once it's installed, then run this command to start it, and then go to this URL, which it tells you. These things, you can see the word train in the top there, giving the impression that you could actually train it in the same way as I trained it with pictures of my face. No chance, not on these laptops. I think I tried to train it on a couple of images, and each image took like 2.5 hours. So it was just couldn't, and my machine was just crying. So it's just, yeah, that's not quite at the point of being able to use. Oh, that's it. Hopefully that gives you a little bit of a idea of how generative art works, and I've tried to touch on the various areas to maybe give you a bit more of an understanding of it all.